Now that we've talked about how light rays sort of bend and they come back and they hit the retina, one of the things we have to look at is how when light is refracted by the lens, it sort of alters the angle a little bit. So if we take the lens and we're going to put an object down here, and we'll put an object up here. Okay. The light rays from the bottom object are going to come up, get bent, and then they're going to get sort of projected onto the retina up here. The light rays from the green object come down, get refracted or bent, and then they are going to get projected down here. So what's projected onto your retina, right, is an image that is upside down. So you might have heard that the image that is projected onto your eye is upside down from what it is in reality. And your brain does some really cool stuff to fix that, right? To update that. Now, what makes this fun is that this is sort of up and down, right? Top and bottom, is that this also sort of happens on a left to right basis. So if we take your two eyes, like so, and we're going to divide them in half, like so, okay? Because what we're going to see is that your left eye has a visual field and your right eye has a visual field. So I'm going to do, let's do gray, and we're going to do this is the visual field of your left eye. It comes over to here about a little bit. All right, so this is the visual field, left eye. And then if we do over here, we've got this as the visual field of your right eye. Okay, so notice that there is an area of overlap, right? So that is your binocular field of view, right? So now what we can see is that this portion here will come back and it will get projected onto the retina over here. This portion from here to here comes back, gets projected onto the retina here and here. Okay, so you have this area here looking over here, this area over here getting information from over here. Okay, now we can do the same thing over here, is that we can get information from here coming over and getting projected over here. Then we can get information from over here being projected and getting projected over here. Okay, so we see how we've got sort of this following backwards, right? So now what happens is that these will have nerve fibers that come back. This has nerve fibers that come back. So does this, and so does this, right? So these are nerve fibers that are going to be transmitted through each of the optic nerves, right? And so if we follow that backwards, right, we are going to have an area where these come back, okay? And there is, we follow the nerve track back. Let's do that. Like so. We're going to hit this area where these two optic nerves enter this chiasm right here. This is your optic chiasm. And so this is where some nerve fibers cross over. Okay, but look what happens is this one's going to come back and it's going to go this way. Okay, this one is going to come back and it's going to go this way. Right, so then what happens is this one comes in and it crosses over. So your medial nerve tracts cross over, but your lateral nerve tracts stay on the same side. They do not cross over. So what you get is you get pink with pink, and then you get green with green. And why that's important is what's going to happen is your brain is going to say, okay, well, what is over here in green and what is over here in green? And what there's going to be is there's just going to be a little bit of overlap right here. And then what's going to happen is your brain's going to say, okay, what's over here in pink and what's over here in pink? And there's going to be a little bit of overlap right there. And your brain is going to find these areas of overlap and it's going to stitch them together. And that's what's going to make one complete picture. So because your medial nerve tracts and the neurons cross over, right, but the laterals stay the same, that allows you to get a complete picture of the entire visual field. So I'm going to put a picture with this so that you can sort of see this all put together with all of these put together and following that back to the brain to see how the brain will look for those areas of overlap. So